To finish off here, obviously volatility is important. When we're forecasting volatility, there is a Nobel Prize winning family of models that put their hand up and say, actually, we have some efficacy. We can forecast the future. Now, they're called volatility models, but actually they're forecasting variance. So be careful of that tripwire. All right. The family, this is an extended family now, it started off as Arch and it's moved into Garch. So essentially Arch would just look at your most recent squared distribution, recent squared deviation from an expected return, and they would use that to forecast what we think variance is going to be. Okay. The generalized version of this, and I'll tell you what this stands for and stuff in a minute. The generalized version uses that dude, that's great, the most recent squared deviation from mean, and it uses the previous estimate for volatility that you've used in this model. Now, when you forecast something tomorrow that uses both those things, that makes it generalized and a little bit more robust than just this thing. Now, when you use something today to forecast tomorrow, or your previous version of something, strictly speaking, that would be your estimate for volatility variance yesterday, and you're updating it for squared deviation that you're seeing today, to get your variance estimate for today. Right? When you're updating something based on its previous estimate for it, that's called autoregressive. Once again, that word auto again, referencing itself. If sigma t squared is driving sigma t plus 1 squared, then it's autoregressive. Okay? It's conditional. Well, I'll come back to that in a moment, but it's heteroskedastic, isn't it? Why? Well, homoskedastic was when variance stayed the same. Heteroskedasticity is where variance changes. Now, heteroskedasticity is a problem for modelers, but if it's just something that seems to happen randomly, that's okay. If it's related to something, then that's a problem. And that's where the conditional comes in. Conditional means your variance is actually related to time in this case. Now, that's a problem if you're trying to model something, but actually it's really cool if you found autoregressive conditional heteroskedasticity. Why? Arch. Why? Because you found that variance is a function of itself, it varies over time, it's a function of time, and we're building a model to do that. We're building a model to forecast where it's going to be. And really all this is just a formulation of like what I said about weather. Hot today, isn't it? Yeah, what do we think tomorrow? Well, hot. Okay, well, we've just seen that, we've just felt the temperature and it's colder. Right, so we start adjusting where we are, but we're sticky to where volatility, currently is, where the temperature currently is. Why it's called conditional? Hopefully I've answered that, Mikhail. It's conditional because it's related to actually, you're forecasting over time, so actually it's related to the independent variable. That's why it's conditional, okay? The independent variable here is time when you're forecasting something over time. Now, we're behind time. Talking of time, we're behind time, so I'm going to